Hey, 7th grade, we're going to be talking about exponents tonight. So hopefully you remember from 6th grade, that you have some number b that is called your base. And then up at the very top in its super tiny little script, we have some kind of number, n, which we call the power or the exponent. And that power is special because it tells us how many times to multiply that base. Okay? For example, if I have 2 to the 4th, I'm going to multiply 2 4 times. 2 is my base. That's the number I keep multiplying. 4 tells me how many times I multiply it. Okay? So that should be stuff you already know. We're going to learn how to multiply with exponents there. So what I mean is, if I have negative 2 cubed times negative 2 squared, how do I multiply these together? Well, I could write it all out and do negative 2 times negative 2 times negative 2, and then this one have negative 2 times negative 2, and multiply negative 2 5 times. That's a lot of work. There's an easier way to do it. When we multiply, we add the exponents. So, if you will notice, I have 5 2's down here. But when I go up here, I have negative 2 to the 3 plus 2 is 5. That matches. Holy cow. So for this to work, the important thing to know is that they must have the same base. And that is super duper important, so I'll put 2 stars by it. If I had like negative 2 to the 3rd and 2 squared, these bases are different. So this adding the exponents thing will not work. Okay? So you have to have the same base. To divide, I cannot spell. Don't tell Miss Eckstein or Miss Allen, but that's why I don't teach it. Okay, so to divide, meaning that I have maybe like negative 5 squared over negative 5 squared. Again, I could write all that out, but if multiplying, we added the exponents, when we divide, we're going to subtract the exponents. So I keep that base, negative 5, and then I subtract down. 2 minus 2 is 0, and anything to the 0th power is 1. Okay, that's important to know if you do not know it already. Okay, so let's try another example of this. Let's say we have 4 squared over 4 to the 4th. I have to have that same base. That's important. So I keep that base. And then I subtract down. 2 minus 4. 2 minus 4 is negative 2. That's kind of a good answer. there's one problem. If I have a negative exponent, I'm going to flip it into my denominator and make it positive. I hope you can see that. Let me rewrite it just in case. I'm flipping it into my denominator and I'm making the exponent positive. So 1 over 4 squared. Because negative, again, just means opposite. So instead of having it in my numerator and it's going to be in my denominator, instead of being negative in the denominator, it's going to be positive. Okay? This one is a little bit harder. See if you can do it on your own. Okay, so you can't multiply across because they don't have the same base. But I can subtract down. 2 minus 3 is negative 1. 5 minus 5 is 0. 4 minus 2 is 2. So I have 5 to the negative 1, 6 to the 0th, 7 squared, which isn't totally simplified yet, because this should really be 1 over 5 to the first, which is just 5. This, anything to the 0th power, is 1. And then this can stay as 7 squared. So if I rewrite this, that would be 7 squared over 5. Now, something funny happens when we have powers on powers on powers. Meaning, what if I have 3 squared times 2 cubed? And I know I can't add the exponents because they're not the same base. And then that whole quantity gets squared. Well, if you would remember the distributive property, I'm going to kind of use it with this exponent. And I'm going to distribute this 2 to the other exponents. And when I do that, I'm going to multiply the exponents. So I should get 3 to the 4th times 2 to the 6th. That's as far as it's going to go. That's okay. This can be my answer. So I know this example has letters in it. You can still do it on your own. Okay. What if I have 2x to the 4th and I'm trying to raise that to the 5th? Well, do I just multiply the 5 times the 4? Or is there another exponent that I'm not seeing here? There is. This 2 is really like 2 to the 1st, which is just 2. So I also have to distribute that 5 over there. So I'm going to have 2 to the 5th, x to the 20th. I do need to go ahead and simplify that. 2 to the 5th is 32, x to the 20th. Okay? Try this one on your own. 2x to the 4th, y, z, all raised to the 5th. You should distribute to the 2, to the x to the 4th, to the y, because that's a first, and then also to that z. So I should get 2 to the 5th, x to the 20th, y to the 5th, z to the 5th, which simplifies to 32, x 20th, y to the 5th, z to the 5th. Final answer. Okay. What about if I was going to divide. Let's say I have 4 cubed, 5 to the 4th. Again, I can't subtract those exponents because I don't have the same base. But if I square the whole thing, what can I do? Well, I'm going to distribute that 2 to my other exponents, here and here. So I will end up getting 4 to the 6th over 5 to the 8th. Again, I'm going to give you one with variables, and you can do it. P to the 4th over Q to the 6th, all raised, oh, I'm sorry, not the 6th, the 9th. And then it's all raised to the 6th. So try this one on your own. You should have gotten P to the 24th over Q to the 54th. I will see you on Monday.